My name is Geoffrey Osborne, and I'm a member of the CData software team. I will be demoing the FireTech connectors today to demonstrate how they work and the various features available in the connectors. Before I jump into the demo, I want to mention a few of the new developments with the connectors. All the FireTech connectors now support the latest 10.3 release of RAD Studio for both Delphi and C++ Builder applications. To install the connectors for RAD Studio 10.3, you can download the setup from cdata.com or via Get-It in RAD Studio. There is a single setup for both RAD Studio 10.2 and 10.3. You'll just need to select which versions you want to install when running the setup. In addition to RAD Studio 10.3 support, CData is continually working to enhance existing drivers with new functionality as well as expand our offering with the implementation of new data sources. Over the past 6 months, we have released over 20 new connectors, some of which are currently in beta but will be fully released in the coming months. This slide provides a list of the new data sources that have been released. So with that, we'll go ahead and get started with the demo. So an overview of the FireTech components. They are a way to connect to your live application, your database, your web services data through SQL-like connectivity. So essentially you can run SQL statements and SQL queries on your various application data, and this is all done through Delphi and C++ Builder applications. So there's a wide number of sources that we support, from CRM and marketing to accounting systems, collaboration ERP systems. We support a wide variety of NoSQL and big data services as well, document and file formats, social networking, etc. So here's kind of a list of all the sources that we support currently, and we're always adding to these. And so essentially, any of these sources that you see here are FireTech components, allow you to connect to them just like you would a SQL database. So you can run SQL selects, inserts, updates, deletes on this data, where applicable, obviously, based on the data source. But you can treat them just like you would a SQL database, and we basically transform the data based on the service, and we transform it to a SQL-like format so that you can execute various queries on them. So it's very allows you to really extend the power of your Delphi and C++ Builder applications, and really just to get the data you want and just to transform it and use it to really extend and expand on your applications that you're building. So it's specifically what I want to kind of go over today is the drivers, kind of the core engine of our drivers, and some of the various features that we provide there that really allow you to extend various web services and to transform and manipulate the data based on your specific need and use case. So it's just a very powerful engine that I just kind of touch a bit on to show you, just kind of give you a glimpse of the various things that you can do with our drivers to transform the data that you're working with on any of these web services. So specifically, I'll talk about our dynamic schema and metadata discovery, as well as our SQL 92 core engine and what we kind of do there. So the first one I'm going to show is our JSON driver, which allows you to connect to either JSON files or JSON web services. So I'm going to be using this Northwind web service here that's available online, and specifically I'm going to look at the customers and orders tables. So these are just two JSON files. So this one here is the customers, and you can see it's an array of customers with IDs, company names, contacts, etc. So there's a good number of records here. And then the second one is orders. And so here you have an order, and then you also have order details, and some of these order details have multiple records to them. So that's just a brief overview of the two tables I'm going to be using today, the two JSON files I'm going to be using today. So to give you an overview of the FireTech components here, so these can be used in Delphi and C++ Builder. They're available via the Get It package manager to download. You can go to the Connectors tab here under Categories, and here you can see the list of all the components that we have here. So these are free to download for a 30-day trial, and they're fully functional trials. So that's where those can be found. So I'm going to start off here. I'm just going to create a new VCL Delphi form here. And I already have the JSON components installed here. And so I'm going to set up a new connection here, go to Connection Editor, and then the driver ID is going to be CData JSON. And so for this particular service here, since we're using a web service, we're going to be using the URI. And so being that the JSON is just a raw file and there's no actual structure to it that we're aware of, I'm going to demonstrate how we will dynamically generate metadata. And so that will generate the tables and the table columns based on the JSON file. So this is done, we have a stored procedure that we do this for, and what it will generate is a schema file, which is a static file that's stored to disk. And from there you can also manipulate that file, which I'll demonstrate, but it'll show you how feature-rich our drivers are, or components are, as well as how extendable they are, and how you can customize them to whatever your needs are there. So for this particular connection, I'm going to set the location here at the bottom. So I'm just going to. So this location is where the static files that we create will be. So I'm going to store them. Oops, I'm going to store them here at JSON demo. And so I have this folder already created here, CJSON demo, that I want to store them in. So I'm just going to store those there. And so I'm going to go to our stored procedure here. So I have the connection set up. And then I'm going to come down here for this particular component and there's no password, so I don't need to enter that. But so I'm going to select the stored proc name, which these are the list of the stored procedures. As you can see, we do support OAuth for various services that provide it, that require it, but we don't need it for this particular service. So I'm just going to go to Create Schema, and then from here I'll do the params, and so here you can see the list of parameters. So I'll kind of go through these here. So table name will be the name of the table that we want to create. So I'm going to do the customers table first here. So this is the customers JSON. I want to call it customers and keep it that way. So I'm going to call it customers. The URI here will be this value. So this is our URL to the JSON document. And so I'll just paste that there. Now our JSON path, so this particular value allows you to specify the repeat element that on which a record in the JSON file will repeat. So in this case, we have this customers array record, which repeats. So we have multiple objects within the array that repeat. So my JSON path is going to be the root and then just customers. And so that will look like, in JSON path syntax, it'll look like that. And so there's that. And then for file location, this is just going to be where I want to store the file. And so this is going to be the same value I set in location. And that is all that is required. The file name, it'll just be based off the table name by default unless I want to rename it. In this case, I don't. And so once I set those, once I execute this, it'll go and read the web service. So go and execute this HTTP request, retrieve this JSON file, and then we will, based on the JSON path that we set, we will dynamically create a schema file. And so I'm going to go ahead and execute this. And so that executed. And now if I go to the directory that I set, I can see I have a customers to RSD file. And so if I open this guy up, so this is our custom schema file. This is the format that we use is it's an XPath or an XML based format. And so kind of do a side by side here so you can see how this was generated. So we parse as customers. Each of these in the JSON path, each of these objects within this customers array is treated as a row. And so each of these name value pairs we then treat as columns. And so as you can see, we have, these are in alphabetical order here. So we have address, city, company name, contact name, country, ID, phone, postal code, etc. And so this is all generated and ready to be used. So if you want to perform a select statement now, you can generate a SQL statement to select, star from customers, and then this will go out, retrieve this JSON file and parse it, and then return it as columns and rows, which I'll demonstrate some of the functionality that we have there. So I'm going to do one more here. I'm going to do the orders table as well. So it's going to be the same exact process. So I'm going to set this to be orders. The URL is just going to change from customers to orders. And my JSON path is going to change here. So this is just going to be results. So I want to return everything within this results. So this is going to change from customers to results. And then my file location will stay the same. So what I'm going to do here is I'm going to go ahead and execute this one. And now I have an orders. And so as you can see here, there is, with there being multiple order details, so we parse this JSON, and then based on the JSON path, we try to flatten everything. So the order details is going to be flattened based on the index within the array, which is seen here based on this XPath value. We flatten it out. So in this particular case, obviously this isn't extremely useful to have it in this format. So what we have some additional options within these RSD files that allows you to transform and manipulate the data. And so for all these, essentially what I want to do in here, in this example, is I want all the orders to be joined to the order details. And basically, so each order detail will be its own row. So I'll show what that looks like here. So I want to get rid of all these, so I don't want to flatten any of these that we had flattened. So I'm just going to get rid of those. And then we have our repeat element, which is at the results. And then we have an option called subrepeat element, which essentially is it's an array inside an array, essentially. So our current repeat element is an array at results. And so what we want to do is have a subrepeat element that is within our result. In this case, it's order details. And so what this will do is this will parse this order details and join it to this order. And then it'll parse this order detail and join it. So in this particular record that we see here, this will be 3 rows, 3 separate rows. And this data here will be joined, or will be duplicated 3 times in this particular example based on number order details. And this can be separated out as well. You can do strictly, if you just want an order details table, you would just set your repeat element to results.order details, which will be, so it look like this. But you'd set your repeat element to that when you execute the store procedure, and it would just parse just this order details table. And so essentially it would get rid of all this order information. If you wanted to break out order, you would do the same thing and just do results.order. And so you could have 2 tables instead of 1. In this case, I just want to join them all into one. And so this subrepeat element here is going to accomplish what I want to do, and having each order detail be joined with the order information on a single row. And there's more information about this in our help documentation as well. It can be a little confusing to understand it at first. So there's more information within our help documentation that's installed with all of our setups. And so I have this table set up, and I have our customers table set up. So I have our 2 tables that I want to use in this example set up with our schema file. And so in this case, I'll show this again here. So with the location, I have set to where I have these stored at. So I set that up initially. And so now let's execute some queries on this. So I'll grab a query. And so I have 2 tables. I have customers and orders. So I'll just do select star from customers. And then I'll go ahead and execute. And so here you can see it retrieved this information from the web service. So I'm going to just click OK on that since that worked, and I will show you some of the options that we have here. We have I'll set this to active, and then we have the option of binding this visually. So I have this query that I just created. I want to link it to a new control, do a t-string grid. I'll just go ahead and expand this out here. So we have some room. And there we go. So here you can see we went out and retrieved the web service data, the JSON data from customers. You can see city is Berlin in Germany, 12209. And that's the same information that we have here. So 12209 in the first record. And so that is that particular query. And just to make sure, so if I do the same thing for orders and execute, and there we have our orders information. So I'll go ahead and set this back to active since I changed it. Okay. And so to give you an idea of what the subrepeat element does here, I will pull up this orders. Alright, so here you can see I'll look at this customer ID of BONAP. So we have 3 records here. And so that's due to this subrepeat element of the order details. So I have 3 order details, so there's 3 records here. If we go down here to RATTC, you can see we have multiple, and that's why we have multiple rows here. And so here you can see with the order details, all the order details are here for each record. So they're basically split out so I can view this information at an order detail level. Alright, so there's that. So that kind of gives you an overview of how we dynamically retrieve metadata. And this is, I did this with JSON just because it's a generic data that you can see that there's no server-side functionality here. We're just going out and retrieving a JSON file, and then we're handling this all in the component itself. So this is just a brief overview of the metadata, and as well as the schema file, and how you can customize this. And to further demonstrate kind of just how we retrieve the metadata and what the component did here is, so in this JSON data we generated the columns based on the names, and these are all customizable. So if we want to get rid of underscore or this order underscore, we can get rid of it. We can change it to whatever we want it to be. We can change it to test, for example. I'll just do test customer ID. So these are completely customizable here. So you can change the names of these. You can change the names of the data types as well. And these data types, we generate these based on the data that is returned. So as we're parsing the JSON document, we identify the data and we determine the data type based on the data that is returned. So whether it's for example, this employee ID is an integer type because they all came back as integer values. Discount, for example, was double, and so being that they're have decimal points, we found them to be a double, and we put them that way. And so all these are customizable. So if you want to change these to, for example, if you don't want this to be an integer, you'd rather have it be a string, you can change it to a string. So this generation that we do is just strictly based on the data that's returned, and then you can customize it to whatever is based on your use cases and your needs. So I'm going to go ahead and put this back the way it was. Okay. So here we have this. I'm going to show you some of the core SQL capabilities that we have. So this was a simple example of a select star. But on top of that, we have full SQL 92 support. So you can do anything from aggregates on this data. You can do filters. You can do where clauses. You can do order bys. You can do group bys. You can do joins. So anything that's SQL 92 compliant, we can do. So in this particular example, being it's just raw JSON files, this is going to be strictly the components. And so I'm going to show you an example of a query that kind of demonstrates all this functionality. So we have a use case here. So we have customers and orders. So we want to get all the company names that we have currently listed within our JSON database and get the total number of orders that each company has made. And so I'm going to do customers dot customer name, or company name. So customers.company name, and I want to do account let's do count on orders dot order ID or customer ID. All right. And so what I'm going to do is I'm going to join these two tables to get that information. So I'm going to do from company name. There's from companies or customers. From customers, I want to do an inner join on orders on. So I want to do customers.id is equal to orders, and I'm going to do order customer ID. And execute. Okay, so in this case, I actually need to add a group by here because I want to group by let's do as order count, and then I want to group by orders.customer ID. Alright, so here we go. So I'm going to set this to active, and so here we go. So this gives us basically the result set of all the companies that we have in our database, as well as all the orders that they have. And so in this case, let's extend this further and say, let's order this by order count. And let's do it in descending order. So let's see who has the most. And so order count. Do OK. And then set this guy back to active so that repopulates. Okay, so that was in ascending order. Missed the descending here. Let's do it in descending order. So who has the most? And here we have the Rattlesnake Canyon Grocery has the most orders with 25, and then Save-A-Lot Markets is 5. So this essentially gives you an overview of how our FireTech components extend functionality that's available for various web services. In this case, it's bare bones JSON. And the FireTech components, the JSON FireTech component, retrieve the data and then internally parse the query in the data and compiled it in exactly the format that you wanted based on your SQL statement. So it just really extends the functionality and the features of various web services. So this is it's as I mentioned before, it's fully SQL 92 compliant, and this goes across the board. And so in this case with JSON, it's a bare web service. In cases of our other providers, such as our NoSQL, our big data databases, various web service out there such as Salesforce, any social networking like Twitter and Facebook, marketing services like Embarcadero, etc. Across the board, how our drivers handle this is that we push based on your SQL statement and what is supported on the server side. We will push as much as we can to the server based on the query that you entered. So if for example, Salesforce supports joins, so if you did a join in Salesforce, we'd push that join to the server side, so it all gets processed on the server side. In the case that there is something that's not supported on the server side, we would process as much as we can on the server side, and then perform the additional processing that is required based on your SQL statement on the client side within the FireTech components. So it really allows you to extend the functionality that's not there on a web service or a database or a software application that we're communicating with, and then allows you to execute exactly the SQL statement that you want to really customize the result set and the data that you want. So it's feature rich, and it's very functional, and it's easy to use in the case that you can really get to the data that you want, and specifically without having to work around all the various API requirements and limitations in that aspect. And so that's a brief overview of some of the functionality that we have here in the FireTech components. And additionally, in regards to metadata, I'm going to show another example here with Elasticsearch, and specifically about how we perform some additional metadata and dynamic metadata discovery. And so I'm just going to go ahead and do a new VCL forms application here. I'm going to go to deconnection. And so I'm going to set up, I already have Elasticsearch installed here as well. So Elasticsearch, just do that, make sure it works. Okay. And so I'm going to do, yeah, so I kind of went through that fast, but for Elasticsearch, I'm not sure what that was. For Elasticsearch, in this particular case, I have a local server set up, so it just requires the server name and then these just basic test credentials that I need. I also want to set this to false initially. So what I'm going to be demonstrating here is the way that we can, so CData, or the Elasticsearch data source, is one that is basically a search database. And so it's all built on JSON. And specifically, what I'm going to be demonstrating here is a way that we can, what we call flatten arrays and flatten objects. So within the JSON, we have the ability to flatten the data based on your needs and your desires here. And so this is all done dynamically. So it works in a similar way that the RSD file would, and this actually has ways of, with this generate schema files, you can generate the schema files exactly like you would JSON, but with Elasticsearch, and then manipulate it in the hard-coded RSD files that way, as I was showing with JSON. And so for this case, I'm just going to show you with nothing flattened sample data set here that I have. And so I actually have it up here. So this is just a sample of the response that will come back. And so in this case, I have one record here to keep it simple. It is going to be, it's basically kind of like an insurance demo. So you have the name of the insured here, their address, which is an object. You have just have a primitive array here of insured ages, so these are all the ages that are on the insurance policy. And then I have a array of objects, which are vehicles. So these are just various vehicles that they have on the insurance policy. And so I'm going to show you how we can flatten this data so you can work with it based on the query that you want to run and what data that you want to retrieve and work with. And so I'm going to do TFD query. So this particular table here is that I'm not going to get too much into the kind of the specifics of Elasticsearch here, but this is basically the schema in the table that I'm going to be working with, and this is all dynamically retrieved as well. So all the schema and table information is all dynamically retrieved. But in this, for the sake of simplicity here, I'm just going to type it out rather than go through those processes, so I can focus on the flattening aspect of it. And so here I'm just going to do a select star. I'm going to go ahead and I'll just execute it. Make sure it worked. Okay, and then I'm just going to go ahead and bind this visually so we can actually see it here. Let's do it two-string grid. Move that out of the way, and then I just need to set this guy back to active here so it displays. Okay. So as you can see here, so I have the street comes back. So this is in the case where nothing's flattened. So it comes back just like at the root elements that come back. So here I'll kind of demonstrate this here. So as you can see here, you have address with the full object in it. We have name, insured ages, and vehicle. So these are all at this root source. And so this is the generic way to just push all the data just at the root element. And so if you want to extend this, so say for example we want to break down any object, any JSON objects into their own columns, so street, city, state, and zip will be their own columns, we have the option to flatten the objects. So I'm going to go to the connection editor, and I'm going to set flatten objects to true. And then I'm going to set this back to active here. And here you can see the columns are different in this case since we've flattened it. So here you have address has been broken into its own columns with city, state, street, and zip with all the values there. So arrays like insured ages, and being that vehicles is an array of objects, this is left in its full format. And so I'll do the next one here, show you. So I'm going to set this back to false and just set flatten arrays. So flatten arrays takes an integer value to the number of arrays that you want to flatten within the. So in this case, I'm just going to do 3 since insured ages has 3 and vehicles has 3. I'm just going to leave it as, I'm going to put it as 3 so we can flatten all those out here. So in this case, I have flatten array set and I have flatten objects turned off. And so here you see address, being that I have flattened objects off, it's a full object. And insured ages has been broken down into 3 separate columns. And for this case, we push the insured ages column with the full array in the case that there is more than 3. Since I specified 3, since there's more than 3 records potentially in the insured ages, so there's no way to ensure based on all the data. And so we always push this column so you can still see the full data and manipulate it if you need to. And since vehicles was an array as well, this is broken into 3 columns as well. So kind of, and this being that it's an object is, so each of these vehicles has its own object in there. And now to further expand this, say we want to break down this vehicles. We say we want to break down each of these vehicles into their own columns. So we want to know each vehicle year, make, and model. And so I'm going to go back here to the connection editor and turn flatten objects on. So we want to flatten everything as much as we can. So I can say OK to this guy, and then I'll reset this. OK. So here we have, obviously, address has been flattened. Insured ages has been flattened. as well. And then specifically what I want to focus on here is the vehicles. So try to give me as much room here as I can to kind of demonstrate this. And so here you have at the first vehicle, which is at index 0 here, has been broken down into each column here. So I'll show you how this is done here with the JSON. So here you have vehicle sub-0, and you have each year, make, model, and body style has been broken into its own columns. And so this will allow you to perform filters on these. So I only have one record in here, but essentially this will allow you to, just to kind of to demonstrate here, if I want to do a where clause and do where vehicles.0.make is equal to Dodge. And so if I execute this, oops, I need to close these in quotes here. If I execute this, you can see I get the record back. And now if I just, to show you that this doesn't work, I'll just do DNE because it doesn't exist, and you can see we don't have any records back. So we did the filter on it, on this particular nested vehicle. So I'll just cancel that. So that just gives you an overview of how we can flatten JSON for a various, and this goes for JSON or XML, basically any kind of format that comes back, we're able to flatten it so that you can customize it to your needs, to your wishes, to your desires that best fit your business needs and your use cases. So it really just extends the functionality of the web service. And in addition to that, we also have we have JSON functions as well. And so if I go, I'll just turn this off, and I'll just set that to false again. And so I will come over to here, and I'll go to the help documentation here for Elasticsearch, FireTech, and I'll show you just some of the SQL functions that we have here. So as you can see, for this particular source, we support inserts, updates, deletes. We support caching, etc. And we also have these custom functions here. So for example, JSON extract. So I'll give you an example of this. So this is additional ways. So if you don't want to flatten it, you can use JSON functions to perform the same kind of customized queries that you would with flattening. So in this case, I will show you here. So we have this address that's all broken out here. So I can do JSON extract, and I want to do address, and then I want to do JSON pass. So this just takes the exact, however the JSON comes back, you give it the JSON pass. So I want to do street, since that's the root element. And I'll just do as street, and then I'll just do one more here on address, and I'll pass in, we'll just do the city, and I'll do it as city. And then I can execute this, and here you see it has broken down the street and the city. So I'll just kind of show this here in a grid view, and there. So instead of flattening it, I just use our JSON functions to parse it and kind of manipulate the data to display only what I want to display, rather than the full raw JSON. And so there's additional JSON functions as well. You can do sums, you can do mins and maxes, and so there's a bunch of aggregations that you can perform on the JSON as well. So it's quite flexible, and it'll really provide you with a lot of various features to manipulate that raw JSON data that comes back for some of the more complex sources. So that's a general overview of just some of the core code and the core engine of across all our FireTech components. At this point, I'm open to any questions that you have, and I'll be happy to answer as best I can any questions that you have. Thank you.